Okay, so we're going to move on to linear combinations now. So there's a place called Detmer Dogs that has a limited menu. It has dogs, buns, and a combination of these. So randomly, meaning with equal probability and independently, you get either a 10 or 18 ounce dog with either a 1 or a 7 ounce bun. So we're going to let D be the weight of a hot dog and B be the weight of a bun. So now, if we look at just the weight of the hot dog, the possible values are 10 and 18. So if you wanted to compute the mean and standard deviation of those, well, you could either do it by hand or you can enter 10 and 18 into your calculator, and we would find that the mean was 14 and the standard deviation was 4. So then to calculate the variance, you take 4 and square it. That gives you 16. To find the range, it's the maximum value minus the minimum value, which would be 8. For the buns, the possible values are 1 and 7. So again, you can average them yourself, but since you need the standard deviation, if you put it on your calculator, you'd need the mean would be 4 and the standard deviation would be 3. The variance then would be 3 squared, or 9, and the range would be 7 minus 1, which is 6. So now we're going to look at what's called the linear combination. You take the possible values for the hot dog and you add them to the possible values for the bun, and then you write down all of the possibilities. So 10 plus 1 would be 11, 10 plus 7 is 17, 18 plus 1 is 19, and 18 plus 7 is 25. So then you can put those 4 values in your calculator, and when you do that, here they are. The mean is 18 and the standard deviation is 5. And so then the variance would be 5 squared, which would be 25. And the range would be the biggest value minus the smallest value, so 25 minus 11, which is 14. Okay. So what we really need to look at, though, are the means and the variances and standard deviation. When you are adding together independent random variables, the means add. So if you look here, 14 plus 4 is equal to 18. So if you need to find the mean of x plus y, you can just take the mean of the x variable and add it to the mean of the y variable. The standard deviations, however, do not add. 4 plus 3 is 7, which is not equal to 5. But if you look at the variances, 16 plus 9 does equal 25. So the variances add. So the variance of x plus y is the variance of x plus the variance of y. Standard deviation, you have to take the square root of the two variances added together. So some people call this the Pythagorean theorem of statistics. You can see it looks similar to the Pythagorean theorem. Okay, so now we're going to look at the next section, which says, suppose we have just our dog, 10 or 18 ounces, and bite randomly with equal probability either a small 1 ounce or a large 3 ounce chomp. Call it C out of it. So now we're going to fill in the next 2 columns of the table. So the possible values for C are 1 and 3. So then the mean is going to be 2, your standard deviation would be 1, so your variance would be 1, and your range would be 2. So you can compute those on your calculator if you wanted. Now if I do D minus C, 10 minus 1 is 9, 10 minus 3 is 7, 18 minus 1 is 17, and 18 minus 7 is, sorry, 18 minus 3 is 15. Did I do those right? Yeah, okay. All right, so then you find the mean and the standard deviation, and you would get 12 ounces, 4.12 ounces. When you square 4.12, you get 17 ounces, and then you get 10 ounces. Okay, So what we're looking at here is when we are subtracting independent random variables. If you look at the means, so if you take 14 minus 2, so D minus C, you do get 12. So the means subtract. So the mean of x minus y is equal to the mean of x minus the mean of y. Okay, if you look at the standard deviation, you can't subtract those. If you look at the variances, those don't subtract either. But if you actually add them, they add. So the variances add. Okay, and the reason is when you're doing x minus y, oops, that should be a sigma squared. That's going to be equal to the variance of x plus a negative y. And that's like having a negative 1 in front of the y. So when you find the variance of that, you're going to take the variance of the x plus negative 1 times the standard deviation of y and square the whole thing. So it turns out that this is equal to the variance of the x plus the variance of the y. And then when you need to find the standard deviation, you would just go ahead and take the square root of that. Okay, so now we're going to look at what happens when you double a random variable. So if we take D and we double the size of the hot dog, 2 times 10 is 20, 2 times 18 is 36. So the mean is 28 ounces, the standard deviation is 8, the variance is 8 squared or 64, and the range is 16. We're not really going to do anything with the ranges, just so you can see that ranges add as well. So now what happens here is the mean did go ahead and double, and the variance, though, didn't double. The variance actually quadrupled. So 16 times 4 is 64. So when we go down here and we double the size, when doubling a random variable, means double. So the mean of 2x is equal to 2 times the mean of x. But variances quadruple. And this is just a linear function like you did a minute ago. So you would have 2 times the standard deviation of x squared. So that ends up giving you 4 times the variance of x. Okay. But now we're going to look at what happens when you add the same random variable to itself. So we're going to smash 2 hot dogs onto the same bun. So when we look at D plus D, well, one option would be 10 plus 10, which would be 20. Another option would be 10 plus 18. So 10 for the first hot dog, 18 for the second one. So that would be 28. Or you could start with an 18-ounce hot dog and add a 10-ounce hot dog to it. So then that would be 28. Or you could add 2 18-ounce hot dogs together and get 36 ounces. Okay, so there's actually more values here than there were with 2 times D. So when you find the average, it's 28. But when you find the standard deviation, it's 5.67. And the variance is less, it's 32. The range is the same at 16. Okay. So when you add 2 values from the same random variable distribution, it's not the same thing as doubling the random variable. So when adding values, So the means are going to double, and the variances also double. Because what's going on when you're doing the mean of x plus x, that does equal the mean of x plus the mean of x, which is equal to 2 times the mean of x. With variances, you're finding the variance of x plus x. So that's the variance of x plus the variance of x. So do you see how these two bottoms were different the way we did them? And so then that gives us 2 times the variance of x. Okay, so 2 times a random variable is a different situation than a random variable plus another random variable. Okay, so big ideas to sum up. Adding or subtracting independent random variables variances add. Variability always increases. The second thing you need to remember is that in math, x plus x equals 2x, or I guess in algebra. But in stats, with random variables, x plus x is not the same as doubling your random variable. Okay, so doubling a single random variable is not the same as adding 2 values of a random variable. So now we're just going to do a few more simple examples applying linear combinations. All right, so linear combinations, the mean, you can just add the combinations together. For variance, though, you need to make sure the variables are independent or this doesn't work. We wouldn't be able to use it with our methods in this class if the variables aren't independent. We don't have enough information. Okay, so we have this example up here. They're the same numbers as we saw previously. If I want you to find the mean and standard deviation of 3x plus 2y, what this says up here is you take 3 times the mean of x plus 2 times the mean of y. And so the mean, we're going to do 3 times the mean of x, which is 8, plus 2 times the mean of y, which is negative 4. And when you add those together, you get 24 minus 8, which is 16. To find the standard deviation, you need to first compute the variance. So that's going to be 3 times the standard deviation of x, and you're going to square that whole quantity, plus 2 times the standard deviation of y, and you're going to square the whole quantity. Up here I have them separated, but you can put them in parentheses and square them both. So that would be 3 times the standard deviation of x was 3. You're going to square that, plus 2 times the standard deviation of y, which is also 2. Square that, so you have 9 squared plus 4 squared, which is 97. And then the standard deviation is going to be the square root of that result, which is approximately 9.849. One more example, find the mean and standard deviation of negative 2x minus 4y. So the mean of negative 2x minus 4y, with these problems, it's usually if there's a second one is a negative, it's best to go ahead and change that to plus a negative. So it's going to be negative 2 times the mean of x plus negative 4 times the mean of y. Making your substitutions, that's going to be negative 2 times 8 plus negative 4 times the mean of y was negative 4. So that's going to be negative 16 plus 16, which equals 0. To find the variance, because you can't compute variances. Okay, so that's going to be negative 2 times the standard deviation of x, square it, plus negative 4